Saxon Math 7-6, Lesson 109. This is a geometry lesson called Corresponding Parts. And this is a very visual lesson. What we're talking about in this lesson is the idea that triangles can match or be equal or be what we call congruent. I don't want this one, I want to change it. Ignore that. Congruent is a geometry word that means equal or matching. Okay, so we are looking at these triangles and we're trying to determine if they are congruent. Now, when we first look at them, putting letters at the corners of them, X, Y, and Z, that's a Y, and A, B, and C. When we first look at them, we go, these triangles are nothing alike. One's standing up, one's lying down, they don't look the same. But if we can rotate, translate, and reflect on these triangles, which we did last week, I think, we see that we can move them into position so that they actually do look the same. And we see that angle A matches to angle X. And angle B, notice how I'm using two lines, goes to angle Y. C and Z match because they're both right angles. Now let's look at the sides. This line corresponds with this line, right? It's the long leg. This is the short leg. And here's the hypotenuse, or the long, like the kitty corner side. So what we have proved is that all the angles are equal. We can say they're equal because we measure them with a number, and we can say that all the sides of the triangle are equal because we can measure their length. And then we can say that the corresponding parts of the triangles are congruent. What do I mean by corresponding parts? Just a second, let me finish writing and I'll tell you. What we mean by corresponding parts is that you have to kind of sync these triangles up with each other in order to see what matches, right? And I indicated the corresponding parts by using a certain number and a certain style of, we call them tick marks. I marked the angles by drawing these little curvy lines in the angle corners, and I indicated the sides that matched with 1, 2, or 3 hash marks. So what I've shown is that the corresponding parts of these triangles are the same or congruent. Okay, this is a super important concept in geometry that we're going to build on for a long time. We just have a fun little example to deal with it. 109.1. John draws us two triangles. 3 inches, 4 inches, and then he's got another one over here that is 4 inches and 5 inches. Okay, and the question is, this is inches too. The question is, what's the perimeter of each of these triangles? Okay, now, what we are supposed to assume, and John does not use the tick marks, which makes me sad, but what we're supposed to assume is that if we rotate and translate and transcribe this triangle, I'm going to draw it again over here. We can make it look just like this. And they'll be the same triangle. They'll be congruent triangles. That's what we're supposed to assume. Now let's see, how do these numbers go? 4 inches on the long side. I circle it sometimes when my diagrams start to get really full, because that way I can keep track of which number goes with which side. And then 3 is here on the bottom. Okay, and then I'm going to circle these just so that everything's circled. This is the one that's too far away. All right, so what we see is that these triangles are congruent, and so we can pull the numbers from one to the other. So what I'm going to do is go, okay, this is 4. This is the side that's 3, and then this side must be 5. Does that make sense? And I could do the same thing here. I could write 3 inches. We can use either triangle as a reference and pull the information from one to the other. I've pulled it to both just so you guys can see really clearly that all three, we can merge the information to get all 3 sides. And then to find the perimeter, we can look at either of these. I'll look at this first one. It's going to be 4 plus 5 plus 3, which means that our perimeter equals 12 inches. Cool, right? Easy, fun, not that bad. Okay, now we're going to a second section in this lesson. And this topic is called similar triangles. I said that weird, it's just the word similar, just like you're used to seeing it. Okay. Triangles can have the same shape, but be of different sizes from each other, okay? This type of triangle that has the same shape but different sizes, in math speak, we say it has equal angles, but different sides. Okay, and the special name that we have for triangles that match those two definitions, this is 2 ways of saying the same thing, we call them similar triangles. And if you think of what the word similar means, if I said those two kids have on a similar shirt, what I would mean by that is that it's not exactly the same, but it's close. It's close enough that it attracts my attention and I notice the similarities. That's, oh, I just used the word. That's kind of like what this word similar means. Close but no cigar, right? They're not exactly the same. I switched pens because this was starting to go. They're not precisely exactly the same. That word, when we have the same shape and the same size, we call that, oh, just a second, let me just write this out. Equal angles. It kind of worked that I switched my pen when I did. Equal angles, equal sides. We call that congruent triangles. So, congruent triangles are a more exclusive club because they have to have not only the same shape and the same size. In similar triangles, they can have different size as long as they're the same shape. I think of these sometimes as click and grab. If you've ever played with shapes on the computer, you know it's a really easy and fun because you can just click on it, grab the corner and pull, and you can stretch the image while keeping the proportions of the sides exactly the same. That's a similar triangle. Click and drag is what I think of when I think of these. Congruent means they're exactly the same, all right? So all congruent triangles are similar because this is the more picky club to be in. Okay, so what are we gonna do with these? easy. Let me flip the page. Okay, this is really, really, really important, you guys. We're going to come back to this again and again in the years ahead, but the difference between congruent and similar has to do with how much matches, right? We're always comparing two triangles when we talk about this, but how much matches. With similar triangles, they have the same angles but different sides, and with congruent triangles, they have equal angles and equal sides. Everything matches up, okay? So they're exactly the same. This is click and drag. Okay, so we're now going to look at one example and then we're done. Example 109.2. The two triangles are similar. What is the measure of angle A? Okay, so here's a little triangle tipped over, lying on its side. Sorry, that's always how I see them. Somebody knocked it over. And then here's a big triangle standing tall. ABC, 60 degrees, 30 degrees. Okay, so we're told that these are similar. And we think, similar, what the heck does that mean? Oh yeah, it means they have equal angles, but different length sides, okay? So, and we're supposed to find out the measure of angle A, this angle. All right, well, if we can pick that one up and carry it over here and stand it next to us, send it next to this big one, then we can compare them more readily. Now I have to carefully relabel my angles. Pretend those match. They don't look very much the same. This is the shorter side. C is at where the right angle is. B is on the other end of the shorter side, and A is up at the top. Okay? That's how you have to think about it. You have to be very careful as you redraw your triangles to make sure you're getting it exactly the same. Okay, so we want to know how much is angle A. Now we can see 30 degrees. Angle A equals 30 degrees. We know the triangles are similar, so we know the angles are the same. We just had to reposition this first triangle so that we could compare. Here's another way to show that the angles match. Put a little hash mark through that line. All right, so angle A equals 30 degrees. Notice that I put a little degree marker on my number that's like putting the unit on it, right? Yay, that's it. That's lesson 109. Thank you.